So hi children, so in this video we are going to discuss about that worksheet 2 problems. Okay, once say that here x and y are any two whole numbers. What is that question? X and y are any two whole numbers. This is not then. Okay, then x divided by y is so one example I am going to tell you that let x is equals to 5 and y is equals to some 10. Okay, so 5 by 10 here I taken. Okay, and this is case 1 and case 2 I am going to take this one as let x is equals to 20 and y is equals to 5. Okay, x is equals to 20 and y is equals to 5. These two numbers I taken now here, two cases. So what is that first one? Always a whole number. If x and y are whole numbers, we know that first condition is always a whole numbers they are saying. In these two cases also we will get that a whole number, then first one satisfying. Okay, once see here 5 by 10. So 5 by 10 means 5 ones, 5 twos. So we will get here this one as 1 by 2. Is 1 by 2 a whole number? 1 by 2 not a whole number. So here we can observe that 1 by 2 that is does not belongs to whole numbers, no. Okay, so come to that second case. Here 20 by 5. Okay, so 5 ones, 5 fours, 20. So here we are getting that 4 as a resultant. So 4 is a whole number, no. So in that first case that is not belongs to whole number. In that second case this is belongs to whole number. Okay, so here always a whole number, this is wrong statement. Why? Because here in one case only we are getting that whole number. In this type of cases we are not getting that whole number, no. So wrong one. Next, never be a whole number, that chance also not there. Why? Because here we are getting a whole number. Never be a whole number means in any case, either case 1 or case 2 we will not get that whole number. But here we are getting a whole number here. So this is also wrong statement. Okay, come to that next one. Maybe a whole number. Okay, maybe a whole number. So here in one case it is not possible. In second case maybe it is possible. In one case it is not possible. Maybe in that second case it is possible. That choice there, no. Here it is not possible, but here it is possible, no. Okay, that's why maybe a whole number, that is okay. Next, is not possible always, which means in case 1 and case 2 also we will not get that a whole number. Okay, that chance is not there, no. Why? Because in this case we are not getting, but the second case we are getting a whole number. That's why we will get maybe a whole number. Okay, either that is a whole number or not a whole number. Okay, but we will get a whole number in some cases. That's why we can say that answer as maybe a whole number. Okay, so option C is that correct answer. Okay, next one. Next is second question. The predecessor of 0 in the set of whole numbers. The predecessor of 0. Predecessor of 0 means 0 minus 1 is equals to minus 1. Okay, the predecessor of 0 is minus 1, but what they are asking? In the set of whole numbers. They are asking that in the set of whole numbers. Okay, that's why this is not belongs to a whole number, no. Okay, minus 1 does not belongs to whole number. That's why answer is does not exist. What is that answer? Does not exist in that whole numbers. Okay, so in that whole numbers which number is not having predecessor? Yes, that is 0. In natural numbers which number is not having predecessor? Yes, that is 1. Okay, so next question is which of the following property is not valid in rational numbers? Not valid in rational numbers. Already we discussed about the properties of all related numbers, no. So in that rational numbers which property is not valid? Okay, so which one is not valid? One say here. So closure property with respect to addition. I will tell you one thing. Addition and subtraction holds that each and every property, I mean in that commutative property, closure property, whatever it may be properties, in all properties addition and multiplication always possible. For that all types of numbers. So no need to say about for that addition and multiplication. Okay, so here these two also possible. Next, come to the next one, closure property with respect to subtraction. Closure property with respect to subtraction. So already we have the table. In the table already we discussed about that. So again I will tell you one example. Closure property with respect to subtraction. So 1 by 2 minus 1 by 3. 1 by 2 minus 1 by 3. So which is equals to closure property only, no? So what is that closure property? If A comma B belongs to rational numbers, according to that rational numbers, then A minus B is also belongs to rational number. That is that closure property, no? So that's why here 1 by 2 is a rational number, 1 by 3 is a rational number. It's a difference. One say that 2 and 3 LCM is 6, and here 3 minus 2 which is equals to 1 by 6. So again this is belongs to rational number only, no? Okay, so in this case it is possible or not? So we may get that integers or rational numbers, or in some way we will get that natural numbers, whole numbers also, no? So these all types of numbers there in that rational numbers. That's why we can say that this is possible for that subtraction. Okay. Next, commutative property with respect to subtraction they are saying. Commutative property means what we discussed. If A and B are any two rational numbers, then A minus B is equals to B minus A. A minus B is equals to B minus A. And already I told you that in addition and multiplication only it is possible. That is, in any way we can add or in any way we can multiple. 2 into 3 is equals to 6 and 3 into 2 is also 6. So there is no change in that. So that is satisfying in all types of numbers, no? So after that, addition. A plus B, 2 plus 3 is equals to 5, 3 plus 2 is equals to 5. If you add those two numbers in any direction, in any order, okay, if you change the order of the numbers, then also the resultant is same. Okay, but come for that here, subtraction. 2 minus 3 is minus 1, 3 minus 2 is 1. There is a difference, no, here. That's why commutative property is not satisfied for that any type of the numbers under subtraction. Okay, simply we can say that commutative property is not satisfying for that any type of numbers under subtraction. Okay, so in the question what they are asking, not valid, not valid they are saying. These three are valid. Okay, these three are valid. Valid means satisfying. So which one is not satisfying? Option D is not satisfying. Okay, once read the question here, they are not asking that which which properties are satisfying here. Which one is not valid means which is not satisfying. So what is that answer here? So here answer is option D. Okay, why? Because these three are satisfying, only D is not satisfying. Okay, so let us see that next one. In the set of whole numbers, the valid operation among the following. Yes, the valid operation again they are asking. So 16 by 4 is equals to 4 by 16. This is 4 fours and here this is 1 by 4. So 4 should not equals to 1 by 4. 4 should not equals to 1 by 4. Okay. Next, this is under addition. Just say that 16 plus 2 is equals to 2 plus 16. 16 plus 2 18. 2 plus 16 18. So LHS is equals to RHS no here. So this is satisfying. Okay. Next say that another one. 1 minus 8 is equals to minus 7. Yes, under closure property. But here what they are asking? In the set of whole numbers they are asking. In whole numbers we can't have that, we didn't have that negative values, no. Negative values are not there in that whole numbers. So that's why this is not satisfying. And in the same way here also this is a negative number. Negative numbers are not there in that whole numbers, no. That's why this is also wrong answer. Okay, so which one is valid here? That is option B, which is 16 plus 2 is equals to 2 plus 16. Okay, so let us see that the next question. Multiplicative identity of real numbers. Multiplicative identity. So which one is multiplicative identity? In any type of numbers, multiplicative identity means what exactly? Here multiplicative identity means if you multiply any number with 1, then you will get the same number itself. Okay, if you multiply any number by 1, then you will get the same number itself. Then we will call that one is called an multiplicative identity. One is called multiplicative identity. Additive identity, that is 0. Okay, if you add 0 to any number, again you will get the same number itself. No, that's why here multiplicative identity in real numbers, in any type of numbers, multiplicative identity is 1. Okay, so let us see the next one. Here 2023 into 2024 into 2022, okay, is equal to 2023 into 24 into 22. So is equal to which property? Here this is in the form of A into B into C. This is in the form of A into B into C. Okay, so which is equals to, this is related to which property? That is related to associative property. Associative property under multiplication, A into B into C is equals to A into brackets of B into C. Just we have to change the brackets, no? So A into B into C. So now which one is correct? 2023 into 2024 into 2022. Just we have to change the brackets. Okay, here plus is given, so this is wrong. And here multiplication, and here positive symbol is given, so that is also wrong. And here positive, this is wrong. Why? Because this is under addition. Under multiplication means just we have to change the brackets only. No need, no, we should not change that symbols. Okay, we should not change that fundamental operations. Just we have to change that only brackets. So which one is correct? Option A is correct. Okay, so next one, the property related to the given operation 2024 plus 0 is equals to 0 plus 2024, which is equals to 2024, which means a number which is added to the given number, then the resultant is the number itself. Okay, when it is possible? If you add 0 to that any number, then only it is possible, right? So here 0 we will call it as additive identity. Okay, multiplicative identity is 1, additive identity is 0. Okay, so the true statement among the following is, what is the true statement? Set of irrational numbers is finite. Irrational numbers are finite. Is it possible? Root 2, root 5, root 2, root 5, root 7, root 11 and so on. Numbers are infinite, right? But here they are saying that set of rational numbers is finite. So this is wrong statement. Next, set of whole numbers is less than 100. Less than 100. Exactly the ending point they are saying 100. So 1 to 100. Whole numbers, no? So 0 to 100. So we can calculate that how many numbers are there from 0 to 100. Okay, it is possible, no? But here they are saying that infinite. Okay, it is possible to count means that is related to finite, but here they given infinite. So this is also wrong. Next, set of integers is infinite. Set of integers infinite. Negative integers, which one is the greatest negative integer? -1. Smallest negative integer? Can't define. And greatest positive integer does not exist. Smallest positive integer is 1. So integers we can say that infinite. Okay, and set of imaginary numbers is not infinite. Set of imaginary numbers also infinite numbers are there. Okay, but here they are saying not infinite. That's why this is also wrong option. Okay, so which one is correct here? Option C is true. Okay, so let us see that next one. Here P into X is equals to P, then the value of X is P into X is equals to P, then the value of X is. Okay, so what is that value here? By which number we will multiply with any number, then you will get the same number itself, by 1. So P into 1 is equals to P. Yes or no? P into 1 is equals to P. Then the value of X, no? So here X is equals to what is that? 1 by 1. Okay, 1 by 1 is nothing but again 1 only, no? That's why. So multiplicative identity they given, so option is C correct here. Option C is correct. Okay, Next, subtraction is commutative in the set of whole numbers. Already I told you that subtraction is not possible for that under commutative. Why? Because if you change the order, then the answer will be changed. Okay, that's why it is a false statement. Okay, so let us see that next one. Here 12 divided by 6, whole divided by again 6. So 6 2's 12, again 2 divided by 6 is equals to 1 by 3. So which option is correct? 1 by 3 is a whole number. No, this is not a whole number. Okay. Next, 1 by 3 is a natural number. No, that is not a natural number. Okay. And a fraction. 1 by 3 is a fraction or not? Yes, 1 by 3 is a fraction. Okay. Next, 1 by 3 is an integer. That is wrong. Okay, 1 by 3 is a fraction. Okay, just we have to simplify that. Okay. So after that, multiplicative identity in the set of complex numbers. I told you that in any type of numbers, a multiplicative identity is always 1 only. Multiplicative identity is always 1 only. Okay. Next, y into x is equals to y. Y into x is equals to y. Then the value of x is, then how it is possible? 0 into 1 is equals to 0. Whatever it may be, y is equals to 0. Any number is multiplied by 1, then you will get that the number itself only, no. Okay. So 0 into 0 is equals to, again we will get that one as 0 only. So which option is correct here? So we can say that 0 by 1, again you will get this one as 0 and here you will get it as 1. Okay, we can take that these two also here. Okay. Next, this is also same as that the previous one only. 2024 divided by 4. Okay, so what you will get here? 2024 divided by 4. So 4 5 20 0 and here 4 6 24. 506. So 506 again divided by 4. Okay, then you will get here any whole number. Not possible. Why? Because here in ones place we have that 6. 6 is not a multiple of 4. What is the divisibility rule of 4? We have to observe that the last two digits of a given number should be divisible by 4. Then the total number is divisible by 4. So here this is not a whole number. And that is a decimal. Yes, that is a decimal. Decimal possible. And in the same way that is a fraction also. 506 by 4 and negative integer is not an answer. Okay. Next, multiplicative inverse of 0 in rational numbers. Multiplicative inverse of 0. Okay, 0 we can write it as 0 by 1. Multiplicative inverse is nothing but reciprocal only, no. So reciprocal of 0 is 1 by 0. So what you will get here? 1 by 0 means it does not exist. Okay, so here multiplicative inverse of 0 is rational numbers, that is does not exist. Okay. So up to here worksheet 2 also completed. So up to here finally number system total concept completed. So you have to practice that more and more questions related to number system. Okay, this is very important concept. Again and again I am saying. Okay, so prepare well for your examination. Okay.